Alright, what's going on everybody? It's Cool Coder here, and today I'm looking at LeetCode's number 19, remove the nth node from the end of the list. So basically we're given the head of a linked list and we want to remove the nth node. You can figure out what that means. So let's say we want to remove the second node from the end of the list. So all we're going to do is this right here, and that's it. So let's talk about how we're going to write this in an algorithm. All right, so like with a lot of linked list questions, we're going to have a dummy node at the beginning, and we can set dummy.next to our current head like this, right? So what we're going to do is we're going to have two pointers. We're going to have a slow pointer and a fast pointer. All right, so after we set our slow and our fast pointers, what we're going to do is we're going to update our fast pointer in time. So let's go ahead and do that. So our fast pointer is going to be here. All right, so we've got our fast and our slow pointers set, and what we're going to do is we're going to increment our fast and our slow pointers, right? So fast will go up 1, and then slow will go up 1. And then our fast will go up 1. And then our slow will go up 1. And then we're going to keep going. And we're going to keep going until fast exists and fast.next. So while fast and fast.next exist, we're going to increment our slow and our fast pointer. And so once we get out of this loop and we've incremented our slow and our fast pointers, you'll notice this is the one we want to remove. So what we're going to do is we're going to remove this pointer or this arrow here. We're going to set slow.next to slow.next.next, right? So we're going to update it. So now the 3 is pointing at the 5. And so this essentially gets rid of this fourth node here, right? So we can basically remove this, and we'll see that now we have removed this fourth node. And so let's look at why we use the slow and the fast pointers like we do. All right, so let's look at this example here, and let's say we want to remove the first node. So the first node from the end. So we're going to have our slow and our fast pointer, and then we're going to update our fast pointer in time. So fast will be here. We can get rid of this, and then we're going to increment our slow and our fast while fast exists and fast.next exists. But you'll notice fast.next does not exist, so we're not ever going to increment our pointers, right? So what we're going to do here is we're going to update, so slow.next, we're going to get rid of this value, and slow.next is going to equal slow.next.next, right? So slow.next.next is going to be here. And so essentially we're going to return a null linked list, right? Because we're going to return dummy.next, which is null, which is exactly what we want because there's only one node in this linked list and we wanted to remove one node. So that's why we use the slow and the fast pointer, and we check for fast exists and fast.next exists. The time complexity for this problem is going to be O of n because we are going to, at worst case, have to go through n elements. And there's going to be no extra memory, so we don't have to worry about that. And that's pretty much it. Let's go ahead and code this up. All right, so remember we're going to first create our dummy node. And we're going to set dummy.next to our current head. And then we're going to have our slow and our fast pointers, and they're both going to start at our dummy node. And then we're going to increment our fast pointer n times, right? So for I in range of n, we want to increment our fast pointer. So fast equals fast.next. And then, so we've updated our fast pointer. So now we're going to increment both pointers until fast is null or fast.next is null. So while fast and fast.next we're going to increment our slow and our fast pointers. So slow is equal to slow.next and fast is equal to fast.next. And then after this, we're going to set slow to equal, we're going to set slow.next to equal slow.next.next. And this is where we're going to bypass the node that we want to remove. So slow.next is going to equal slow.next.next. And then at the very end, we can go ahead and return our dummy.next because that's going to be the dummy.next is going to be the new head of our linked list. Let's run it and make sure it works. And there you go. It's simple as that. Thanks for watching. Hope you learned something. Please like and subscribe, and I'll see you on the next one.